Day 147, Honors Physics, Kirchoff's Laws, example 42. This problem actually is going to have two solutions. I've done some preliminary work here, but let me refresh your memory once again. What I first have done is I've labeled my junctions. There's only two junctions here. There's point A and point B. I've labeled some other points on the corners for when I do my loop rules, but A and B are the only junctions here. So there are branches that connect those. There's a branch here in the middle. There's this branch over here on the right, and a branch over here on the left. So what I've noticed people in class doing wrong is they've been drawing their currents in loops. You want to draw or assign your, this is step 2 here, my branch currents. There are 3 branches here in this diagram. One is given, that's this 1 amp current right here. Now the thing is, I don't know if it's like I have it here to the left or counterclockwise. I've assigned that, but I'll do the problem over again where I have this current going the other way. I don't know which way it's going, but I know it's 1 amp right here. I think this was the intended solution, but we'll see. Maybe not. 1 amp going this way. Well, I do know that this 12-volt battery is stronger than the 10-volt battery. 12 volts, potential difference is more than 10. So I do know that for sure that this current is going to go this way, and that this current has to be bigger than this current, no matter which way this current goes. So by default, essentially, this current has to go down. We'll come back to that, but this current has to go clockwise, so I know that's correct. This could go the other way. We'll do that solution later, and this branch current is going to go down. So I have my 3 branch currents, not loop currents. I apply the loop rule for voltages in loops, but my currents must be assigned to branches from one junction to another, not in a loop. All right, so I think what I'll do now is I will take my loop rule and apply it over here to this loop. I'm going to do that. It'll magically appear. So I've chosen to start at point B and go around this loop this way and apply my second law. The voltages must add up to 0. In this loop there are 3 elements here. So generically I said V1 plus V2 plus V3 equals 0. I also know, and I could have stated that up at the top here, that for this 2 ohm resistor, V equals IR, this is going to be 2 volts potential difference, because I is 1 amp as given, and 2 ohms, 1 times 2 is 2 volts there. So anyway, if I go around that loop, everything's conventional. I'm going with my assigned current flows, with this 1 amp to the left here, or counterclockwise, and then down here. So everything's conventional. I'm going to have the plus 10 for the battery, minus 2 volts for that top resistor, minus V sub 3. V sub 3 is therefore 8 volts. So now things fall into place very quickly. If I know I have 8 volts in this resistor right here, and its resistance is 4 ohms, V equals IR, that means I sub 3, it will be 2 amps. You can do that in your head, and I'll write that on the diagram. This is 2 amps current, I sub 3. And now I can just apply the loop rule to the left-hand loop, the small loop. I'll do that magically. Well, it's not magic, it's applying Kirchoff's second law, and that is I took the loop BFEAB, and once again I'm going with all the conventional arrows that I've assigned. So everything will take on its normal signs. So I'll have a plus 12 volts from my V sub 1, and then minus the voltage of that unknown resistor at the top, V sub R, minus the 8 volts for that 4 ohm resistor in the middle, equals 0. So V sub R is 4 volts. At the very, very top up there, this guy is 4 volts. I also know, going back to Kirchoff's first law, if I look at point A, right here, I know there's 1 amp coming in that was given, and this I sub 3 was 2 amps, so I have 2 amps coming out from A to B, and 1 amp only going in so far. So I sub 2, by deduction, I sub 2 is 1 amp. So that's my applying Kirchoff's first law. I sub 2 is 1 amp. Whoops, 1 amp. That's a 1 right there. All right, I also could have set up at the top here, this I right here is I sub 3. That's I sub 3. That's a 3 right there. Anyway, if I know that I sub 2 is 1 amp, I can apply Ohm's law. V equals IR to that unknown R resistor up there. V is 4 volts equals I of 1 amp. Well, pretty simple. Oh, I is 1 amp there. That's supposed to be a 1. That right there is a 1. So R is 4 ohms. All right, so plug in 1 for I there, you get R is 4 ohms. So that's one solution to this problem. R could be 4 ohms. Now I'll try this with the current, the 1 amp current that's given going to the right in that 2 ohm resistor. So I'll start over on the next page. Okay, so I've redrawn a diagram and done some preliminary work here. So the only difference in the diagram right now, I think I have the same lettering, is I have this current going clockwise now. The 1 amp going this way instead of the way I had it on the first diagram. And I have I sub 2 and I sub 3 as they were in the first diagram. I'm doing the same loop again. I'm doing loop B, C, D, A, but we have some unconventional directions here. I have 3 elements, but if I'm going in this loop, applying the voltage rule, the 10 volts is still positive, so that's still 10 for V sub 1. But as I walk from D to A, as I go in that direction now, I'm going against my assigned current arrow. I'm walking from D to A to the left, and my current arrow is to the right. So instead of a normal minus 2 volts for that resistor, once again, that's a 2 volt resistor because I know the current's 1 amp and the resistance is 2 ohms. So that's a 2 volt potential difference for that resistor. But in the equation now, I put plus 2 instead of minus 2. And then I come down from A to B, and I'm going in the direction of the I sub 3 current. So that's a conventional negative voltage for that 4 ohm resistor. So it's you can see this pretty easily, that V sub 4 then would have to be 12 volts in this situation. Well, if V sub 4 is 12, you can apply Ohm's law in your head. V equals IR to this. So I know I sub 3 well, V is 12 volts. I can write that down. 12 volts there for that resistor, that 4 ohm resistor. So I sub 3 is 3 amps. 12 divided by 4 is 3 amps. And if I have 3 amps going from A to B, down that way, and 1 amp going from A to D, that's all current coming out of point A. So the current going into point A is this current right here. It's the only current going in. So that has to add up to 3 plus 1 is 4. That has to be 4 amps in this branch, which is different than before. And now I can apply the loop rule to this loop. I'll do that and come back to you. All right, so I applied the loop rule to loop BFEAB. So same loop that I did before. And bottom line is, the only way this works is if the resistor is 0, well, the voltage is 0, and therefore R is 0. So I guess you could call this a second solution. It's not really a second solution because now we don't have a resistor that's 0 volts and 0 ohms. So this only is consistent if R is 0 ohms. So I would go with the first solution. I guess if you want to be nitpicky, you could say, well, if R is 0, this circuit could be as I just outlined here. But the better solution is that first solution.